Okay, well, welcome everyone, and thank you for joining us today. But before we move to our speaker, I'd like to go over a few housekeeping items. Change
Yes,
over?
we're just gonna give Carrie her quick introduction. We're really glad that she's here today. I've really enjoyed the past month working together to get this webinar put together. Carrie did her undergraduate work at Smith College in the area of child study and education. She received her master's in learning disabilities from Columbia Teachers College in 1982. She's worked with students with learning disabilities ever since. Carrie has run private remedial programs, and starting in 1995, she began teaching math at the Newgrange School, where she worked for 8 years, the last 2 as the math coordinator. There, she and her team helped create a math curriculum that aligned with the core curriculum content standards and met the needs of students with learning disabilities. In 2003, Carrie helped start the Bridge Academy in Lawrenceville, New Jersey, an independent, state-accredited school for children with learning disabilities. Here, she worked as math coordinator, teaching math to ages 8 to 18, and mentored new teachers with ongoing professional development. While at the Bridge Academy, Carrie was a member of the school management team, the admissions committee, and the curriculum committee. She and her team worked to fine-tune their math curriculum to meet the needs of their students, incorporating research with best classroom practices. In 2007, when she moved to Maine, Carrie began the process of writing down the curriculum in a series of 3 books under the title Bridging the Gap of Mathematics. She continued to work with the staff at the Bridge Academy through quarterly visits and weekly Skype meetings. In addition, Carrie has continued to give workshops at national and international venues, including a school for students with learning disabilities in Kenya, Africa. She's recently finished the 3rd book of the supplemental curriculum, which will be published in early 2014. And on top of all that, Carrie is a mom of 3 and has had experience as parenting children with learning differences. In order to get us started today, we're actually going to do a quick poll about what grade your children are in, and that will kind of give Carrie some guidance on the types of examples to give. So Jennifer B., if you don't mind pushing out our poll.
Yeah, I'll launch it right now.
Take a quick moment to give us grades K through 3, grades 4 through 6, 7 through 9, or 10 through 12. We have found that we've got a really great balance of ages that are typically represented in these sessions, so it'll be exciting to kind of see where our grades are in that.
Okay, so let's
All
see.
right, so our results today, Carrie, so you kind of get an idea of our audience. We've got about 9% in the grades K through 3. In grades 4 through 6, we've got 50%. 7 through 9, 27%, and 10 through 12, 14%. And so that middle section of grades 4 through 6 is where the majority of our participants are. Well, if we can go ahead and let Carrie be the presenter, and we'll be able to start the math content. Carrie, we're really glad that you're here today.
I am thrilled to be a part of this. This is really exciting. And I just want to say to everyone out there, this is my very first webcam, and so if things go, I think everything's going to go great, but I'm excited to be trying this, and I hope that I can answer questions for you guys. I'm speaking to you from beautiful Maine, where the colors are starting to fade, but it's still pretty gorgeous up here. I want to get started by, first of all, giving as much of a definition to dyscalculia as we can, as much as one can ever do that. It means a severe or complicated inability to calculate. Dyscalculia actually refers to a wide range of lifelong learning disabilities involving math. There's really no single form of math disability, and difficulties can vary from person to person and affect people differently in school and throughout life. It involves problems learning math skills and concepts, and roughly 5 to 8% of school-age children are identified as having a math disability. Learning disability in mathematics, or math disability, is really a term that's more widely used today than dyscalculia, because we're trying to be as inclusive of our kids as we can be. Mastering mathematics, as you all know as parents and educators, is an ongoing process. Children are constantly integrating new and sophisticated skills and concepts as they solve increasingly more advanced math problems. Concepts that are learned in first grade are built upon in subsequent grades, so a breakdown at any stage can cause future problems. And I'm not surprised to see that the bulk of our parents here are in that upper elementary, middle school area, because that's where a lot of math problems start to occur. It's where they show up. It's the point at which, you know, K through 3, they're kind of building the skills, and they expect them to have them by 4th grade and be able to use them. So if they haven't gotten some of those basic skills, the math difficulties are going to start showing up at those grades. Symptoms of a math disability can be any of these things, and really for the past 6 months it should not just be an isolated incident, but should be an ongoing issue with understanding one-to-one correspondence between number, symbols, and object. And by that I mean most of us can look at that picture of the 4 hearts and without counting 1, 2, 3, 4 know that that means 4. That's a spatial relation piece of information that is critical for all children to have, because they use it in everything that they do. Being able to count and calculate rapidly, learning and memorizing basic facts, and by that I mean automaticity, that they know them just instantly, that not that they can rely on a strategy, but they absolutely know them very quickly. Children could have difficulties learning counting strategies, not being able to count by 3s, 5s, 10s, 100, and so on. And developing math problem-solving skills. There are strategies that children are taught, but if they can't own those strategies and come up with them on their own, and this is a continual problem, they may have a math disability. It can also turn up in learning multiplication tables, formulas, and rules, learning math vocabulary, making comparisons such as more than, less than, estimating numbers and quantities, measuring, telling time, making change. All of these are things that are lifelong skills that if your child has been having trouble with these for a series of 6 months or so, you might be encountering an actual math disability, not just a trouble with a specific topic. What does dyslexia actually look like in the math classroom? I'm going to start by saying that my role has always been an educator, and I'm as a mom also, but the thing that I always found exciting was I felt like I was working with a puzzle each day that I went to work. The labels really have very little meaning for educators. When working through the puzzle of how to get the information into the student's brain, the label is not exactly helpful. At least for me as an educator, I've never found it helpful. I know that we need to put labels on our children to get them the services they need. However, as an educator or as someone working with a child, I'm much more interested in what are their learning strengths. For example, are they a visual, kinesthetic, auditory learner? Do they learn whole to part in math problems, or do they learn part to whole? Are they a child that sees the answer quickly without doing the steps, or are they a child that needs to know each and every step? And also, what are their learning challenges? Do they have attention issues? Do they have memory issues? Do they have learning processing speed issues? All of these help to put together a profile of a child, and that's what I look at when I am designing how I'm going to deliver the math material to the children. There are 4 categories of difficulties that children can have in math in general: memory, language, attention, and spatial temporal sequential problems. Let's discuss these one at a time, and then I'm going to go through and talk about what you as a parent can do with each of these issues if you recognize your child in this. Memory problems. Almost every kind of memory you can think of occurs when learning math. Memory helps students use previously learned material and link it to new material, and when you can link new material to the old material in your brain, you are solidifying it in memory. If you are unable to make that link, you're not going to be able to make those memories. It can be a factual memory for recalling facts automatically. It could be a procedural memory for following multiple steps. Your child could have problems with active working memory, which includes holding on to previous information or working on something while working on something else. An example of that is if asked to multiply 12 times 25, a lot of people would think, well, 10 times 25 is 250, and 2 times 25 is 50. So if I add 250 and 50, I get 300. So 12 times 25 is 300. Or people might break that 12 into groups, 3 groups of 4, and knowing that a group of 4 times 25 is 100, so 3 groups would be 300. Being able to hold on to one little piece of information while you're manipulating another piece of information and then bring those two together, that's active working memory. And we ask children to use that a lot in math because it's there are lots of multiple steps going on. Another area where children could have difficulty is in memory problems is pattern recognition, and here you need long-term memory. Children are being asked all the time to identify a pattern, whether the pattern of a problem, oh, this problem reminds me of a problem I did last week, and when I did it last week, I used this process. So that's the kind of pattern, and retrieving from long-term memory a method that has worked in the past for the pattern. And then a memory for rules. There are lots and lots of rules, and a lot of kids think that math is the people that are successful at math are the ones that can remember all of the tricks for math and all of the rules for math. I maintain that if when teaching the material to the children, they are discovering the rules themselves, they will go into their memory in a very different way. And so I will endeavor to help you as parents figure out how to do that. Another problem we might run into is a language problem. The language demands of math are extensive. I get very frustrated, and I just was reading in the paper this morning that when they were defining dyslexia and they were talking all about reading and writing, and math never came into it. The language of math is the second language all children learn. It involves reception, comprehension, and production. If you look at this example that I have on the screen, we have an addition sign there, and I've put up how complicated the language of math can be. I've written 5 possible words, add, plus, combine, total, sum, that mean that one symbol. You could probably come up with 5 more, and your neighbor could come up with 5 different ones. One of the activities I like to do with my students is we have them come up with, we give them the symbols and we tell them to take it home and discuss with their parents and their family all the different words that mean that symbol that we have in our world. But if you think about the demands that we have on children for just remembering that this symbol can show up in a lot of different words, it's huge. Another way language problems occur, obviously, in word problems, written or oral directions, depending on whether there's an auditory processing or a visual processing issue with the directions. In word problems, identifying the important information or the extra information and ferreting that out from what's needed. And unlike reading, the meaning of a math word usually can't be inferred from its context. If the directions say, find the total in these problems, and there's nothing in those directions that tells the child that total means they're going to have to add. So it's very different from reading in that way. Attention problems are a huge issue for math. My eldest had a lot of attention issues, and I used to do a lot of strategies with him to get him to pay attention. A lot of my students had attention issues. Attention to details like operation signs. If you think about a test, a worksheet, many, many times there are multiple operations on the page or even within problems. And so I will give some strategies for helping kids pay attention to those if attention is an issue for them. Kids with attention difficulties often ignore decimal points. They have a hard time discerning the important information in the problem. keeping track of where they are in multi-step problems means that they have to go back to the beginning and then start all over again, and then they lose track again, which slows down their work. And they are not real good at going back and checking their work because they're at the point that they finish, they're just moving on to the next thing. So getting them to slow down and check their work is also a challenge if you have attention issues. Spatial and temporal sequential problems. Visual spatial problems can show up in visually recognizing symbols and numbers, being able to visualize them as the teacher talks about them. If I say to you, 3 plus 4 equals 7. Most of you, if you don't have a visual spatial issue, will be able to visualize in your brain a horizontal or a vertical problem where you have a 3, a 4, an addition sign, an equal sign, and a 7 after it or at the bottom. Kids with visual spatial problems have difficulty doing that. And a lot of the times when teachers are teaching, they will be doing that orally, and the ability to bring it up in your brain as a picture can be difficult for these kids. They also have trouble misaligning numbers in columns, which means that they will very often have difficulties with place value. And when maps and geometry come into play in their math classroom, it can be very challenging for them. Temporal sequential problems, math is loaded with sequences. We are constantly saying, order of operations, first you do this, then you do this. Many problems have multiple steps. And the sequence, the order is very, very important. So kids with sequential problems are going to have difficulty with those, and with multi-step problems doing it in the correct order.